Hello everyone, my name is Guruprasad KN, Assistant Professor, Department of Electronics and Communication Engineering, ATM College of Engineering, Mysuru. Today I will be demonstrating how to conduct emitter follower circuit using Multisim. So the aim of this experiment is to design, implement and test an emitter follower, which is also commonly known as common collector amplifier, and to analyze its voltage gain characteristics using Multisim. And the objective of this experiment is to observe the waveforms and verify whether the gain is equal to 1 and how this emitter follower acts as a buffer. This is the circuit diagram. So in the circuit diagram we can find we have a transistor 2N, 2222A, 4 resistors R1, R2, R3, R4, 2 capacitors, coupling capacitors, 1 microfarad each, a function generator and an oscillator. Now let me draw the circuit using Multisim. So I am opening the NI Multisim. So first let me go to the all groups. So here let me choose the transistor. Since I have already chosen the transistor, it's available. So let me take once again 2N, 2222A, drop the transistor. Then I require resistors. So choose the resistor, place it here, and I also require capacitors, and we can place the capacitor. I require power supply, so go to the source, power supply, choose VCC and place it here, and I also require ground. I'll keep the ground. Now this capacitor has to be oriented, so you can press Ctrl R, it will shift, it will rotate clockwise 90°, and I need 4 such resistors, so I will use copy paste option. And I require one more capacitor. So the value of R1 is 1 kilo ohm, R2 let me choose 6.8 kilo ohms, and this one R3 I am choosing it as 560 ohms, and R4 as 10 kilo ohms, and both the capacitors are 1 microfarad each, and this power supply I am changing it to 12 volts. Now let me do the connections. So this R3 I am connecting to the emitter. And let me choose input device function generator and the output device oscilloscope. I need ground connections for these two. So this common is grounded. Similarly in the CRO, both the negative terminals are grounded. So connect the output through emitter. This connection is not made. I will do that connection. And this load resistance, one side I will connect to the capacitor, other one to the ground. Similarly, another coupling capacitor I will connect to the base and other side to the function generator. Now let me change the parameters here. So let me set frequency of function generator to 1 kilohertz, amplitude to 2 volts. Then I have to check input and output at a time. So I will use another channel, channel B, for the input, and let me change its color so that it is easy to differentiate between input and output signals. Now all my circuit elements are completed. So this R4 should be 10 kilo ohm. Check, is there any component, the values are proper or not. Then once everything is completed, then click on the run and double click on the CRO. So now I am changing these values. Time base, let me set it to 1 millisecond per division. Channel A 2 volts per division, channel B 2 volts per division. Let me reverse it. I will click on single to stop this one. Now in the channel A, I am seeing the output, channel B input. So channel B is blue color. So I am shifting upwards. Y position is 1. Similarly, I am bringing output downwards with Y position -1. So I can clearly observe here, the blue color is input signal and the red one is output, and input is equal to output. So that means the emitter follower circuit, the input and output both will be same and there will not be any phase shift. So if we keep these waveforms one above the other, there will be 0-degree phase shift. So let me check what is the voltage here. So in the channel B, if I see, the value is 1.972 volts. So if I see similarly, I can see here also channel A 1.923. So both are almost 1.9 volts. So input and output both are equal. So this completes emitter follower experiment, which is also commonly known as common collector circuit. Thank you everyone for watching the video.